Okay, now we're to the purification part. I did a lot of the math here. You guys can look at that if you like, of the reaction between ammonium chloride and sodium perchlorate to make ammonium perchlorate and salt. And I have the moles of it. So I have my test mole. To make 0.1 mole, you need about 12 grams of the perchlorate and 5 grams of the chloride. So I'll do that test here in just a moment. But before I do that, I'm going to continue with our purification. So up here, you can see I've got about 450 grams of the sodium chlorate here now. I've got quite a bit more in the bag still, but I'm going to start out with this much, put it all in my flask thingy, and then pour in the acetone and distill it over, and then we'll be able to recycle that. A slight oversight on my part. I had 500 grams of sodium perchlorate here, and I was going to put in almost a liter of acetone, but that flask right there is only actually able to hold 100 milliliters. So I adjusted the amount. There should be 30 in there from how much is left in here. I'm now going to do, I'm going to try to do about 200 grams in there at a time. So using about 200 milliliters of acetone. So I'll have to do smaller batches than I thought. Okay, I've got my acetone measured out, a little over 400. I'm gonna pour that in. Oh, a little bit falling down there, okay. Perfect. Now that should be enough to dissolve it all, but I'm going to go ahead and stir it around a little bit to make sure it all is dissolved. Okay, after dissolving it all in the acetone, I actually topped it up a good bit and added maybe 100 milliliters more of acetone just to really make sure it all dissolved. Shook it around a little bit, stirred it. There's still a little bit of powder on the bottom. I'm trying to think that might be chlorate, since that was at the bottom of the cell, but I mixed in a little bit later. So I'm just going to go ahead and filter that off now, and then take the filtrate, put it back in there, and then evaporate the acetone off, and we should have our pretty pure perchlorate in there after that. And we should have our chlorate in here. I'll do a couple more tests just to make sure though. Alright, we ended up filtering off what appears to be the chlorate. I went ahead and washed it again with a lot more acetone, and it's still not dissolving, so I think that's either sodium chloride or sodium chlorate. I'll filter that off more a little bit later, but I went ahead and washed my round bottom flask with some more acetone, and now I'm going to go ahead and put this in here. I'm going to set up my distillation apparatus and get my acetone back before moving on to this big bag of perchlorate. I might just save that for later in case I need it, but I'll go ahead and start this next step. Okay, right here we have our sodium perchlorate acetone solution boiling. That should be pretty much 99.9% sodium perchlorate in there right now, but I'm still going to try and get a little bit purer. So we have the boiling acetone. This should be, to anyone who understands, this should be a little bit scary since it's oxidizer and a fuel together. Our demonstration showed it might not be as dangerous as one might think at first glance, but still something that should be respected. So you can see here, it's coming over. We've got quite a bit of pure acetone coming over. That will be reused. This will probably take 30 minutes. But once we get all of it out, it'll be ready for future batches whenever we decide to do that. After we finished the acetone purification, I have my bag right here. This should be almost entirely sodium perchlorate with a tiny bit of sodium chlorate still in it, since it was also soluble in acetone up to 1/10 of a gram. But I'm actually going to try to remove that as well, since I really want to prevent ammonium chlorate from forming. So I'm going to do one last purification step using hydrochloric acid before we finally mix these two to make our ammonium perchlorate. So I'm going to be using hydrochloric acid, and I'm just going to mix it in the solution with the perchlorate. And the hydrochloric acid will attack the chlorate ion. It'll turn a little bit yellow. It'll release some scary chlorine and chlorine oxide gas. But as long as you do it outside and make sure you're not breathing the fumes, it should be okay. We just boil it all out and we should be left with just sodium chloride, just salt, and our perchlorate. And I'm not going to be picky and trying to remove the rest of the chloride with acetone again, but you could if you want, I suppose. Okay, we got our hydrochloric acid right here, about 30%, plus our water. Since there's only a tiny bit of chlorate, I imagine actually being in there, I'm going to go ahead and dilute it in the water. Make sure to remember the acid goes into the water, not the water into the acid, because sometimes adding water to acid can be very heat generating and can boil. So I imagine that's enough, probably. I didn't do any of the math on this one, although I probably should have, honestly. Then this just goes in here. As you can see, it's not even really turning yellow, which is a really good sign that we don't really have much chlorate in there to start with. Really good sign. So these fumes are actually explosive at concentrations above 10%, although like I said, we will have probably hardly any fumes whatsoever at all. So we'll probably fine. And then, just so you guys know what to expect, after we finish boiling all the water out of this, I actually have some indigo carmine still, so we will be using that to finally make sure that our chlorate is down to less than, I think it's 1 part per million is how much it tests for. So let's go ahead and start that. You can see a couple bubbles here on the top. I think those are the only little bits of chlorate that actually are reacting, because it is the just 1/10 of a gram. We had a 1/10 of a gram for 100 milliliters, and we only put in 200 grams of our starting solution, so it should be pretty dang low. I think this is just chlorine gas in these bubbles here, so not much at all. I've isolated a little bit of what was in there. It's turning a little bit yellow-green. I think it's breaking stuff down. Maybe it just needed heat. So actually, since it has hydrochloric acid, it's actually super acidic right now. As long as we add indigo carmine, this will be the perfect reagent to test if there's chlorate in it still. So we'll go ahead and add a little bit. If it stays blue, it means there is none. Pretty much none. If it... Okay, looks like there's still a little bit of chlorate in there. Maybe it just needs to break down with some heat still. So I'll just keep boiling this. And we started frothing up and putting out some pretty thick white fumes, so I think we're actually getting to the reaction now. This is actually my first time doing it, so I'm not sure. But looks like we're going to find out together. I paused the reaction for a couple hours while I went to church, but I'm back, so I started it back up again. There's a little bit of indigo carmine, like a couple tests I did. I put it in the beaker, then I ended up pouring it back in. So you can see it's actually changing to more of like a green, slightly blue color. So I think we're ready here. I took a little bit of the cell solution and put it in here. So let's test it. And you can see it is kind of hard to see, but it's a little bit blue. That means that the solution should now have a couple parts per million of chlorate, which is very good. It means there's virtually no chlorate in it. So we're just going to go ahead and boil the rest of this down now, and we'll have our very pure perchlorate product. Okay, the next thing we have to do now that we've confirmed that there's pretty much zero chlorate in here is actually to neutralize it. acidic oxidizers are very dangerous, so we're going to go ahead and, you can see it says 0, so it's very acidic still. Lots of hydrochloric acid. We're going to add some sodium hydroxide until this is a pH of about 7 or even a tiny bit higher to make sure this is safe when we add fuels to it later. Okay, after I put in the sodium hydroxide crystals, it actually formed this like weird white thing in it. It looked kind of like a polymer at first. I kind of stirred it around and broke them up. So it's like little clumps now. So not sure what that is. Not sure if it's an impurity in one of the things I used. But we are going to find out if that's going to mess up our process. Right here towards the end you can see it's a little bit green. I think it's because of the indigo carmine. So yeah, if you want it to look pretty, maybe you shouldn't put it back in there, because otherwise it'll do that. I may have messed something up. I have no idea what it's trying to do now. It's too yellow to be indigo carmine, I think. I'm just going to recrystallize it and see if there's anything I can save up from this. I'm not sure what it's doing when it does this, but it's really cool to watch. It kind of looks like a brain. I don't really want to mix it because it's going to destroy the design. But that's super cool. I wonder what makes it do that.